Before we start, guys, just quick comment. We recommend you guys running this tutorial on a Linux machine. Granted, you can build Yocto on other operating systems, like, for example, Windows or Mac. But it's gonna be a pain. But I already tried it. You need to use a Docker container. I mean, it works. Like, so at the end of the day, it works. But it's like I tried on my Mac a few times, and it was just such a big pain that I just moved into a Linux machine. I've always been using Linux. Like, I've been using Linux since I started working on embedded, and Linux is cool, guys. So yeah, recommended Linux machine. So before we start, let's assume that you guys have, kind of like a clean sheet in terms of your computer. So we will need to be installing the dependencies. So that's very easy. That's very easy to fix. Just go into developer wiki ProventusNova.com. And then in the main page, if you scroll down a little bit, you will find the create custom Yocto meta layer wiki. In there, you will find in the prerequisites the instructions on how to install the required packages on Ubuntu that you need. So, like if it's Ubuntu, you just do sudo apt install and then run this command. However, if you're using a different Linux distro, you can just kind of go ahead and Google that and figure it out. Let us know if you have issues, so it can help you. So we can help you kind of go past them. So I'm gonna go ahead and copy this command. I'm gonna have it install those I'm gonna have it install the packages. However, since I already have this installed, probably it's gonna do nothing. But yeah, so you just run that. It'll say okay, so it seems like everything is there, but there's some upgradable packages, so I'm gonna upgrade them just to make sure that I'm up to date. Then just gonna go to a little repo here. Well, not a repo, a little directory here that I created just kind of to do tutorials into, and we can get started. So first thing we need to do is essentially we can just kind of follow this guy alone, because this guy, like this wiki was written if you wanted to create like it was written using a Jetson device. It was just for creating an NVIDIA a meta layer for a Jetson or NX. However, as mentioned, Yocto is pretty cool. It doesn't really matter like what platform you're going to be using. The only thing that's going to change is the layers that you're going to be using. For example, for a NVIDIA board, you will also obviously going to be requiring the meta open for Tegra layer and other kind of like meta Tegra layers that you might need. For in this case, since we're going to be working with the MediaTek board, what you're going to be requiring is the recipes, or not the recipes, the layers that MediaTek puts out. So we're going to go through that in a little bit. So let's go ahead and start with a repo. We will need to create a repo for this. So what we're going to do is, let me think about this, because I want to do this in such a way. Okay, well, no issue. All right, let's go into GitHub. So github.com. We're gonna name this MediaTek So it's gonna be named like that just because Meta, ProventusNova, and then MediaTek. Very cool, right? So let's do that. Let's call this. So this is gonna be our I don't know, sample MediaTek demo distro. So MediaTek demo distro by, let's call MediaTek demo distro by ProventusNova. It's gonna be public, no issue. That's code that you guys are gonna be able to access and just clone and build. So that's gonna be cool. And then let's add a README. Git ignore. We can just don't add anything later. We can just choose whatever we want to ignore. And license. Let's call this non-license or whatever. So we're gonna create that repo. Okay, so we now have a repo. We have main. So let's go ahead and do. Okay, let's go ahead and clone this very quickly. So in tutorials, we're gonna do a git clone, and we're gonna do this. I think this might give me issues just because I have no issues. It just worked like a charm. So yeah, ProventusNova, Meta BNMTK. Okay, so we now have MetaP and MTK. So let's go into there. And now what we're gonna do is we're gonna start by creating our Git history. Like the idea is just not only to show you guys how to do the Yocto, but also you guys can take some tips if you want of how to manage repos. We have a very specific way of managing repos because we make sure that the history is very clean. That allows us to later do maintenance very easily, or to find where specific features were added or stuff like that. So the idea is we're gonna branch out of main with a develop branch, then we're gonna branch out of develop with feature branches. Whenever we have feature ready, we just merge those features into develop, and then whenever we have a release ready, we merge develop into main in this case, and then we hit we create a release right there. So let's start by doing that. So we're gonna start by creating the develop branch. Then we're now in develop. So but develop, we're not going to be committing straight to develop, right? That's the thing. So we're going to creating a feature branch called, I don't know, let's do git checkout dash b feature, and let's see what our wiki says. So let's go ahead and see what our first step here to create a layer is. So first of all, okay, so we see that we have like we created a meta ProventusNova, in this case directory. This is going to be our meta pnmtk here. There's no reason for you to do other like at the directory name, basically the name inside of the repo directory. You can just do it right there on the root level of your repo. So then we're going to be creating the config file, well, the conf directory, the layer conf, and then the readme. I'm going to go through which like each of those in a bit. Well, the readme we already have because we created on the git and the git UI. So if you do, for example, ls, you'll see the readme right there. That's cool. So now what we can do is just so we're going to create a conf named directory. That directory is going to have all our configurations. For example, we're going to start by adding the layer configuration, which is the very base layer, the very base configuration file we need to add. But then we can add, like in that same directory, we're going to add, for example, the machines later on. We're also going to add the configuration files for the build, for the Yocto build. So yeah, but let's go step by step. Okay, cool. Let's do the layer.conf file. So what I'm going to be doing for this is I'm going to do just code. I don't know what IDE you guys use, but code is pretty cool. So what we're going to be doing is we're going to be copying this configuration file right here from our wiki. So that's already, oops, thought I was on the Mac, so no command key here. So okay, cool. Now all right, so conf, we're gonna create a new file called layer.conf, and this is gonna be the configuration file for our own meta layer, right? So Yocto is like an onion, or a Yocto builds like an onion, and you have different layers. So essentially you start with a very base layer, which is like, usually the very base layer is just Yocto layer, right? Like bulky and all that. But then on top of that, you start adding layers. Like for example, if you're gonna be working with a MediaTek board, then the next layer you're gonna add is the MediaTek layer, so that you can have support for the hardware that MediaTek provides, right? Then let's say that you're gonna use a frame sensor. So if you're gonna use a frameless camera sensor, probably you will need some sort of layer for that. Then let's say that you wanna use oh no, like whatever you want to use. Like in this case, for example, we're going to be creating this custom layer. So if someone wants to replicate our project, they need to use our layer for it. So that's cool, right? It's like an onion. So we're going to be working on a layer, and this layer configuration file will allow you to specify different stuff like whenever Yocto is going to be building your layer. So this configuration file will tell Yocto like how your layer is configured, and we're going to go step by step here on what these things mean. But it's very simple. Like for example, here the bb path variable, environment variable, just defines what the layer, where the layer stores the recipes. So in this case, it just kind of uses this other environment variable, which is layer dir. Then we have the bb files. Essentially, this doesn't change for any layer that you're going to be creating. It just tells Yocto, hey, look here for the recipe files that we have in this layer, right? So essentially, it's just that. It's telling Yocto where to look for when Yocto tries to find BB files, which are the recipes, which we already discussed earlier in the video. You know, recipes are the way you define or tell Yocto how to add support for different packages, and that's what a layer does, essentially. And then what's next here is the BB collections. So these other variables here, what they do is just they define kind of like names and stuff that Yocto is going to be using. This is also not very important. So in our case, what we're going to be doing here is, since our meta layer is no longer called meta ProventusNova, we're going to change that to whatever our layer name is. So in our case, the layer is called meta pnmtk, right? So what we're going to be doing is we're going to be creating so we're gonna call this pn-mtk. Okay, so for and actually let's do kind of like a quick swap of everything. So everything that's called ProventusNova now takes the name of our layer. Our layer is named pn-mtk, so we're gonna name it like that. So pn-mtk, which remember that stands for ProventusNova MediaTek. Then this priority here is very important. This is something you might actually need to play with later on. And what this tells Yocto is like, what's the priority of this layer when compared to the other layers? And the lower number, the lower priority it has, the higher number, the higher priority it has. And what this does is, like, for example, let's say that you're using another layer. Like, let's say that you have that you're using a layer that, I don't know, adds support for a certain GStreamer feature, and then you want to have your layer add that same support, but then you have a different recipe for it, right? Like, let's say that you add changes on top of it. So essentially, as long as your priority, as long as the priority on your layer is higher than the other layer's priority, your layer's changes will come on top. If not, then the layer's changes will come on top of your changes. So that is important to understand, right? So the thing that we need to make sure we understand here is, like, whatever, like, the priority determines what changes are going to go on top of what other changes. So if two different layers add, or two layers or more have the same changes on a recipe, or have changes on a recipe, essentially the one that with the highest priority is going to come on top. So that's how, like, all of them are going to apply. Don't get me wrong. Like, if you have you know, BB append after BB append after BB append, then whenever there's conflicts, that's where one will rule over the other. But if there are no conflicts, like, all the BB appends are going to apply very easily. But this essentially will tell Yocto, hey, like, in this case, we're using a pretty high priority here. Like, this was taken from MetaTegra. MetaTegra does that. MetaTegra has a very high priority just because there's a bunch of different layers coming into it, and they wanted MetaTegra to be kind of the highest one. In our case, we wanted also to be the highest one, so we added the same priority. But this we can change. Like, for example, if we're going to be doing for MTK, we can lower this to whatever makes sense to use. In this case, we're just going to leave it to 50. That's going to ensure that our layer comes on top every time. Then the layer version, this is just a kind of like a versioning thing we need to use. This is very important too. The layer series compat, this determines what's gonna be like with, like, Yocto has different versions, right? So for example, you might have a Scarlet Gap right here, which is, I think, one of the latest ones. Then you have Kirkstone, then you have, I don't know, like, they go all the way to the very beginning where, you know, you had Sumo and other versions. So essentially, this tells Yocto what Yocto versions is this layer compatible with, right? So if you want this layer to be comparable with only Scarlet Gap, then you do Scarlet Gap. But then if you want this to be comparable with other, like Sumo or Warrior or whatever, then you just need to add here. For example, if you wanted this to be compatible with Kirkstone, you will come here and write Kirkstone, right? But right now we're gonna be just using Scarlet Gap. Or, well, I don't quite remember, because we'll need to look into what the MediaTek layer supports. I think it was Kirkstone based, so we'll need to look into that. We might want to change this to Kirkstone, but let's just leave it like that for the moment, and then we can start working on it later. This is used by the, okay, so this is used by the Tegra Distro sanity checker. So since this is all Meta Tegra stuff, we don't need it. We're working with MediaTek boards here, so let's just remove that. Okay. So essentially, this is how our layers coming is going to be configured for now. We can just go ahead and double check with the MediaTek. So it's called GitLab MediaTek AIoT. One I just to confirm is what version of Yocto we're going to be using, so that we can use the same. And let's go look for it. So their main like for MediaTek, their main, like they have a bunch of meta layers here on the repo, obviously. So, but their main kind of like meta layer for their images is called MetaReady. I don't really know what where the ready comes from, but let me see if I can find that over here. So if you can see, like, what this is a meta, kind of like a repo called MetaReady. Inside of it, we have even more meta layers, but we're gonna go into the MetaReady demo. That's the one that they ask kind of like people to use whenever they're following, whenever you're following kind of like their whenever you're following their tutorials. So let's go ahead and look into the MetaReady demo, the conf directory. Now you guys know that the conf directory will hold the configurations for the layer at least, and any other stuff that they want to configure at a distro level. So in here you will see they have the ready demo conf, right? We could even base off of this if we wanted. Like, we could change our completely configure, or we could change our layer configuration to match this one, which makes even more sense than just using the one that we had here, which is a little bit more simplistic. But yeah, we can even do that. Like, if you guys want, we can go ahead and just come here, and I'm gonna take the raw file. I'm just gonna replace all this that we just did. And if you guys see, it actually has the same things. So BB path, it's around here. So let me see if I can see that. Wow, I don't actually see it here. Well, that's interesting. So maybe they're just using the default, because there's obviously a default BB path defined for this. So what we're gonna be doing is, so let's just use this. What they, okay, so there you go. So what they are doing here is they require this ready.inc from conf distro. So, and on top of that, they're just adding a bunch of different stuff. So we can just go ahead and take a look at what what the ready include has to offer, and then we can decide whether we wanna. Okay, so let me see. So conf distro ready.inc conf. Okay, no, no. Okay, cool. So that was the reason why I was different. Cool. Now I look like a dumb. Like I don't know. So yeah, so let's go ahead and compare this to this. For example, now we were comparing different things. We'll go into what I was just copying wrongly here. It was just the distro configuration file, so it is different from the layer configuration file. That's why it was so different. So now let's compare these two. So we have the, like, from this line to here is MediaTek. This is the one that we grabbed from our wiki. It's more NVIDIA like. So you will see that we have the VB path, like that's on every layer configuration file, the VB files, then the VB dynamics. These ones, you can see that they are for software update. So we can either remove that for now, because, like, for example, the recipe file here from MediaTek doesn't have them. And that is mostly because this software update stuff is for OTA updates. And we can just remove that for the time being, and we can just add that later, or we can just leave it there. Like, it's not gonna do much. So let's just remove it so that it kind of like stays sane with what the MediaTek have there. And then, okay, so they have the BB path, they have the BB files, then they have the collections, and they have their patterns, right? Then they have their priority. So you see the priority is 9, so we can lower our priority to 9 if we want. Then here's what we actually came for, which is, okay, let me see. So they have this should be only incremented in changes, so it calls okay. So this is for the layer version, so let's just leave it there. And then they have the layer depends ready demo. So this layer essentially depends on all these other layers, like core, MediaTek BSP, MediaTek TSN, Bluedroid, demo layer. So this just essentially tells Yocto, hey, if you wanted to build this layer, then you will need to comply with this with all these dependencies, right? And then this is what we actually came for, which is very funny. So we actually came for it, just looking for this specific value. We wanted to know if we were going to be able to use ScarletGraph, for example, for our compat. But as you can see here, MediaTek is currently using Kirkston. And one thing that we can do is actually, because I recall that they synced their branch to a specific, well, they sync their build to a specific branch, which is this one, refs. So I'm gonna go ahead and sync it to this one just to make sure that we are using what they suggest using for building the Yocto layer. So I'm gonna go ahead and come here because this is Kirkston. So I'm just gonna go ahead and look for this. Oops, let me see why it's not. Okay, so this is a tag. It's not a branch. So I'm gonna go ahead and come here. Let me see if I can find the tag. So tag is ready card cap. So I'm gonna just do this. There you go. So this is the tag, ready card cap bit 250. This is the config file. Once more, we're gonna go ahead and copy that. I'm just gonna replace the whole thing now that I have explained what that is. So yeah, so just replace the whole thing. We're gonna be basing off of this specific layer configuration file. We started with the one that we had on the wiki, and however now we're just gonna be using whatever MediaTek suggests we use, right? So they suggest using this one, right, based on their wikis. So we're gonna be using this one as we saw. We still have the BB path, the BB files, the BBA, everything. So we're gonna be changing this ready demo for what our meta layer is called. If you guys recall, we called it PN-MTK. So we're just gonna kind of do this, and do this, and then we're gonna replace all read demo appearances with PN-MTK. So PN-MTK, that's our layer name, and this we're not going to change because as they suggest here, it's better not to change it. And then they have this fix me remove layers, and then okay, I don't know, this is an interesting comment. Yeah, we're just gonna leave it like that for the time being. These are all the layers they can require, and as you can see, actually this is very interesting. So see, since we changed since we changed to this new version, release card cap, now on the tag on the git repo, now we see that actually they added support for scarlet cap, which is the newer version of Yocto, which is cool because it is better to use kind of whatever is newer on Yocto, however newer but stable, right? Because Yocto also has that thing, which is, since it is maintained by the community, what could happen is like people are just kind of pushing changes constantly. So if you're not using something that's stable, it might break your build. That's something that we're going to try to fix later. There's a couple ways we can do that. Like for example, we could use either a manifest just to keep track of kind of, so we can sync our build to specific commits on every single meta layer, or we can use something like, for example, git submodules, which is also very useful. But yeah, so for the time being, we're just going to be using this. Okay, cool. Now we have our layer.conf file. I just noticed that I have a typo here, so I'm just kind of like rename it. So rename layer.conf instead of .con, and that should fix it. So yeah, let's go check our wiki because we are already done with our first step. So yeah, in here we already did that. So we're gonna just commit this just to keep it clean. So our first commit is at base layer.conf file. So we're gonna, oh, oops, no, not Mac once again. That's cool. Okay, but yeah, so I'm gonna just create this commit really quickly. It's gonna keep it clean. So we're gonna give git status. You will see that we will have this conf file that is not tracked. So we're gonna be doing git add conf layer conf git status once again, just to make sure. So we have a file right there. We're gonna do git commit -m. Then we're gonna add this commit message, which makes a lot of sense. Actually, the wiki is hard done in such a way that you can just kind of use the steps as commit messages, and that's gonna keep a very clean git history. So git commit, okay, we're gonna do this real quick. All right, we have a commit, git log, there you go. Cool, right? So now let's see what we need to do next. So we can do a tree if you guys want, so you can see that we are kind of compliant with this structure. So So if you do 3 dot, then you'll see that you have the meta. Well, we're outside the. You can do 3 dot dot. I think I'm not sure what. Yeah. So we have the meta pn mtk, which is this meta ProventusNova. Then we have the conf directory. Inside we have the layer.conf and then the readme. So we are all good to go. We're right within what we need to do in order to get this right done.